Hi, geometry students. Today we're going to work on the Outbreak Lab Module 3. So there's a little background here that you can read about. It says, basically now that you can monitor what goes inside the quarantined area, it's time to cure the infected population. And so you have this medication and you're trying to basically split off your area basically into 3 groups. You don't want to necessarily give it to everybody at once. You want to make sure basically that it's working well, and it kind of explains stuff like this. There could be side effects, so you're trying to kind of give it to one group at a time. And so it says to determine the amount of people that will need medication in each section, you first have to determine the area of each of the sections. And so we'll be using some mathematical reasoning in order to find the areas. So it says here to determine the length of the arc, if we're trying to rope off the sections, which is what we're going to do first, then we'll need to use arc length. And that's going to involve circumference of the circle. So again, we're going to rope it off the sections. That's going to involve arc length or circumference, and then we're going to try to figure out how much medication we're going to give to the people, and then that's kind of going to go with area. Okay, so here's our map again. We've had that before. That's the map of Detroit. And it says here, using proportional reasoning, write a formula that you could use to find the arc length, or the length of an arc made by a central angle with a measure of 45 degrees. So again, you have to think, what's the formula for circumference? And so it kind of showed you up here. The formula for circumference is 2 pi r. Okay, and so we want to know then, if we're roping off a section, we want to know like what's the arc length going to be, so we know how much rope to use. All right, so write the formula that you could use to find the length of an arc with a measure of 45 degrees. So I'm going to write it, you write it here, but I'm going to, of course, write it on a different piece of paper, so I don't have to write on this. So again, circumference is 2 pi r, okay? And so if you're thinking of it in terms of that formula, we're only using a part of the circumference. If we use, for 45 degrees, okay, we're thinking of what fraction of the circumference are we using. So we do 45 over, and then how many degrees are there in a circle? Well, there are 360. So this fraction here represents the portion of the circumference you're taking. So for our specific arc length, it's going to be, for this question, 45 over 360 times 2 pi r. Okay, so again, this is the arc length for 40, like a 45 degree angle. So it's a fraction of the circumference, because you're not taking all of the circumference. So then the next question is, write a general formula that you could use to find the length of an arc made by a central angle with a measure of x, so any angle. So then on that blank, instead of 45, we're going to use x. So in general, arc length, I don't know what I was wanting to write there, is x over 360 times 2 pi r, meaning it's a fraction of the circle. And again, it's a fraction of the circumference of the circle. So that's the first part. So if we're trying to rope off a certain section, we'll apply that to this. I think that's in step 2. So turning it over, It says here, oh, this is question number 3. You want to section off the 3 sections of the sick population so you can keep track of which section of Detroit is getting which dosage. And again, maybe you can try to do something with that information. You have 3 different dosages you will be giving. So you cut your circle into 3 sections, each with a central angle of 360 divided by 3. That'll give you even sections. So 120 degrees is that angle. Estimate the radius of the day 3 circle using the scale in the bottom left corner of the map. And then using that, how much rope will you need to rope off one section? So again, use this arc length. So the arc length here for this particular thing, for roping off, so I guess this is question 1, 2, here's 3. So we're roping off 120 degrees out of 360. That's actually, it reduces to a third, but you can write that this way for now. And then 2 pi, and then r. What is r? So if we look back on this thing right here, day 3, when I measured this out, I got about 1.25 miles using this down here. And again, yours might be slightly different. I was just using like something minor, like just roughly, just kind of using this idea here, and then maybe adding on another quarter. So I got 1 1/4, just rough estimation. But you can use, if you like, you can use a ruler and be exact. But yeah, just for the sake of doing this, we're just kind of guessing it. So yeah, this is what we have to do then. Come back to this. So it's a 120 degree sector, and then that's 2 pi times 1.25. Okay? And then if I put this in my calculator, I'll use, I can actually do degrees or radians, either one, but I'm going to do this. So this is a third. So I'll start with this. 2 times pi times 1.25. That's 7.85. And then, again, this is a third, so I'm just going to divide that by 3. So 2.62. And remember, I used miles, so that means my answer is actually in miles. When I did my measuring, I used miles. So that's the arc length, but it asked for how much rope you're going to need. Remember, if you're splitting your section off, we just found this curved amount here. We found this arc length right here. We just found this curved amount. So this right here is 2.62 miles going around here. But remember, we need to rope off this as well. That's our radius. So 1.25 and 1.25. So add, that's basically 2.5 right there. So just add another 2.5 to your answer and you get 5.12. So 5.12, and again, this is miles. So that's a lot of rope. So that's the total, 5.12 miles of rope. So I'm not sure if they're actually using rope, but again, in the context of this question, that's what we would have. So now that was step 1. Step 2. Okay, and this is what we're going to be doing today as well. What is the constant K of proportionality for the equation of the length of an arc? So for step 2, okay, here's the equation. S equals pi over pi, x over 360 times 2 pi r. So that's kind of what we were talking about earlier. That's the arc length represented by s. And again, it's a fraction of your circumference. So arc length depends on the angle and the radius. Okay, so our constant of proportionality, excluding the radius, basically, that's like if you've got like a proportional equation, it looks like this. Okay, y equals kx, and k is your constant of proportionality. So if you're thinking in terms of that, r is kind of like our x value in a way, and then all this other stuff is like your k, your constant of proportionality. So that's the constant of proportionality. Okay, and if we rearrange that, just basically to put this, if we put the 360 underneath this, we get x times 2 pi over 360. Okay? And I like to simplify this, but they didn't want to. So this also simplifies to pi over 180, which is really a conversion factor, a special thing. It's a conversion factor that you can use to convert between radians and degrees. Okay? So then I ask on here, the next question, what is the definition of a radian? And how many go around any circle, and what does that mean? So if you think about what a radian is, it's an angle that's formed by taking the length of the radius and wrapping it around the edge of the circle. So if I were to draw a picture of that, let's say here's my radius. That same length right there, okay? If I take that same length and wrap it, so this is r, if I wrap r around if I take that length of r and I wrap it, I try to wrap, imagine a string, I guess. I try to wrap it around the circle, so that's also r, but it's like bent. That right there, the angle that forms using that radius is called 1 radian. So, and again, I wrote this over here. If you want to look at this definition right here, radian definition. So the angle formed by taking the length of the radius and wrapping it around the edge of the circle it creates. Okay? So you can replay that if you need to, or look back at that, pause it. So for any circle, if you were to look at any circle, no matter what the radius is, it would take 6.28 of these to go all the way around the circle, no matter what your radius is. Okay? That's also equal to 2 pi. So also that, pi is like 3.14. So 3.14 times 2 is like 6.28. So those are the two things right there. So that's how many it takes to go all the way around the circle. And you know that the distance around a circle is 360 degrees. Okay, if you go all the way around a circle, that's 360 degrees. So if you're wrapping your radians around, it takes 6.28 radians to get around the circle, or 2 pi to get around the circle, versus 360 degrees to get around the circle. So those are related. So you can kind of see that this is like a conversion factor between radians and degrees, because these are both the same. They're both, this is in radians. It says it takes 6.28 to get around the circle, and this is 360. Okay, so that's a kind of a neat little relationship. And so they have here theta, okay, your angle, basically is going to be x times 2 pi over 360, okay? And again, x is your angle measurement. Remember, ours is 120. So I think for this final question, here it says in step 1 we found the length was 120. What's the measure of this angle in radians? So if we use this, basically we can use this right here to convert. You're taking your angle in degrees and you're multiplying it by really pi over 180 or 2 pi over 360. If you do that, you're converting it to radians because the pi is on the top. If you were to multiply it this way, you could convert from radians to degrees. But on this one, we're converting from degrees to radians. Hope that makes sense. So 120 times 2 pi over 360. That's going to be our theta in radians. Okay, that's what they want to know. That was the third question on step 2. So I know 120 goes into 360 3 times. So I'm going to divide 120 by 120. I get 1. Divide 360 by 120. I get 3. So theta equals 2 pi over 3. So that is the answer in radians for 120 degrees. And that ends step 2.